Okay, hello everybody, what's going on? This is Muhammad. Welcome to another video. In this video, I'm going to teach you how to solve for this problem. So we have this quadratic equation, ax squared plus bx plus c equals 0, whose roots are alpha and beta, and whose coefficients a, b, c are basically distinct, non-zero real numbers, and they are in arithmetic progression. If 1 over alpha plus 1 over beta, alpha plus beta, alpha squared plus beta squared, they form also a geometric progression. So the question is to solve for a over c. So how to solve for this problem? Basically, we need to remember what is meant by arithmetic progression and geometric progression. When we say that is that A, B, C are in arithmetic progression, that means they form an arithmetic sequence, which means that the difference between C and B is the same as the difference between B and C. So the difference between any two consecutive elements is basically constant. And when we say geometric progression, that means that the division of any two consecutive elements is basically constant as well. Okay, so we're going to benefit from these two facts to solve for this problem. So first of all, I will start by the quadratic equation, which is ax squared plus bx plus c equals 0, and we can basically normalize this quadratic equation by dividing every element by a. So with that, we're going to get x squared plus b over a x plus c over a equals 0. And since this quadratic equation has alpha and beta as its roots, so basically we can equate this with x minus alpha multiplied by x minus beta, and that is going to be equal to 0. And if we distribute the two terms here, the two parentheses on each other, then we're going to get x squared plus alpha plus beta. So I guess negative here, we have a negative sign. Alpha plus beta x plus alpha beta, and that is going to be equal to 0. If we equate the terms on both sides, then we find out that b over a is going to be equal to minus alpha plus beta, and I will call this equation number 1. And also, alpha beta is going to be equal to c over a, so c over a is going to be equal to alpha beta, and I will call this equation number 2. Okay, so now basically the question is asking us to find a over c, which is basically 1 over alpha beta, because alpha beta is c over a, so the reciprocal of that is going to be equal to a over c. Okay, so first of all, I will start by the coefficients a, b, and c. So a, b, c are an arithmetic progression, is an arithmetic sequence. So that tells us, so if a, b, c is an arithmetic progression, then if we divide all the elements by c, okay, then a over c, b over c, then that would also give us, they will also be an arithmetic progression. So they will form also an arithmetic sequence, okay, is also an arithmetic sequence. Okay, so that tells us, because this a over c, b over c, and 1 are an arithmetic progression, so the difference between any two consecutive elements is basically constant. So 1, that implies that 1 minus b over c is equal to b over c minus a over c, which tells us that twice b over c is basically equal to 1 plus a over c, and from that we can get an equation for b over c, which is equal to half by multiplying both sides by half. That's going to give us half plus half A over C, and I will call this equation number 3. Okay, so we're gonna use that equation in the next steps. Okay, now, so we have benefited in this step, in this stage, from the fact that the coefficients A, B, and C are an arithmetic progression. Now we're gonna benefit from the idea that that 1 over alpha plus 1 over beta, alpha plus beta and alpha squared plus beta squared are in geometric progression, So that tells us that these three elements are a part of a geometric sequence, which means, okay, that the division, if we divide any two consecutive terms, that's going to give us a constant value. So that implies that alpha, if we divide this element here by this element, okay, first of all, let's rewrite the first element. The first element, 1 over alpha plus 1 over beta, can be rewritten as alpha plus beta. Okay, so basically that tells us that alpha plus beta over alpha plus beta, and alpha squared plus beta squared are in arithmetic progression, which tells us that these three elements here form an arithmetic sequence. Okay, so that means that if we divide this term here by this term and this term here by this term again, that's going to give us a constant value. So if we divide the second term by the first term, that's going to give us alpha beta. And if we divide this third term by the second term, that's going to give us alpha squared plus beta squared over alpha plus beta, which can be rewritten as alpha plus beta all squared minus twice alpha beta divided by alpha plus beta. And this can be rewritten if we split the numerator over the denominator. So that's going to give us alpha plus beta minus twice alpha beta over alpha plus beta. Okay? So we're going to call this equation number 4. Okay. Now we're going to go back to... we're going to rewrite equation number 4 in terms of A, B, and C. So we're going to benefit from equation number 3 to do that. Okay, so first of all, alpha beta, we can go back to equation number 2 and substitute C over A, which can be also substituted as 1 over A over C. Okay, so alpha beta is basically 1 over, 1 over A over C, which is basically what we're solving for. Alpha plus beta, we can go back to equation number 1, that's minus B over A. And minus twice. Now alpha beta divided by alpha plus beta, how can we write that? Okay, alpha beta is basically alpha beta. We can go back to equation number 2 and substitute C over A instead of alpha beta. So C divided by A. And alpha plus beta from equation number 1, it's minus B over A. That's going to give us 1 over A divided by C. And minus B over A can be rewritten as minus B over C multiplied by C over A minus, and this thing here can be rewritten as minus C, minus with minus, that's going to give us plus C. A is going to get cancelled with A, and we're going to be left out with twice C over B. C over B, which we basically solved for in equation number 3, the reciprocal of that, okay? So 2 divided by b over c, so we can rewrite that again. Okay, so 1 over ac, let's rewrite that in a better way. 1 over ac equals minus b over c. We can benefit from equation number 3 and substitute b over c in terms of a over c, which is what we're solving for actually. So that's going to give us minus outside, and between two parentheses half plus half, and b over c is, yes, a over c. A over c. And outside, so that's basically b over c. And we have c over a outside, which is c over a. Or basically, yeah, let's leave it like that. Okay, and plus 2 c over b is basically can be rewritten as 2 divided by b over c, which is basically half plus half, half plus half a over c. Okay, so we can go ahead and let x equals a over c. So with that, that would simplify things a lot. Okay, so 1 over ac can be rewritten as 1 over x, and that's going to give us minus, between two parentheses, minus half plus half. Now a over c is basically x, okay, and c over a is 1 over x, which is the reciprocal of that, plus twice half plus half, and a over c is nothing but x, okay? Now, we can simplify this expression. So that's going to give us 1 over x equals minus 1 over 2x minus 1 half plus, now x plus 1 divided by 2. The 2 is going to, we're going to get that to the numerator, so that's going to give us 4 divided by x plus 1. Now we're going to go ahead and multiply every term by 2x multiplied by x plus 1. So that's going to leave us with twice x plus 1 on the left-hand side. And on the right-hand side, we're going to multiply that by 2x, which is going to get cancelled. And we're going to be left out with minus x plus 1 minus x multiplied by x plus 1 plus 4 multiplied by 2x, so that's going to give us 8x actually. Okay, so here 2x plus 2, plus 2, that is going to give us minus x minus 1 minus x squared minus 1 plus 8x. So we're going to get x squared to the other side, minus x, this is x here. So minus x minus 2x plus 8x, that's 6x. If we get it to the other side, that's going to give us minus 6x added to 2x, so that's going to give us minus 4x. And plus 2, and the minus 1 is going to become plus 1, so it's going to become plus 3 equals 0. And if we factorize this, that's going to give us x 3, 1 minus equals 0. So x is going to be equal to either 3 or x is equal to 1. But since a and b and c are distinct, remember that x is a over c, and a and c are distinct from each other, so they can't be 1. So we're going to ignore the 1. Why? Because a, b, and c are distinct. So we're going to be left out with x equals 3. So that tells us that a over c is equal to 3. And that is the answer to this problem. If you like this problem and the solution, hit like. And don't forget to subscribe to the channel and click the bell so you don't miss anything in the future. Thank you for watching, and see you in another video.